Hi everyone, and thanks for joining us on our talk about interacting body and textile expressions becoming with digital movement translation. The presented research aimed at exploring digital technology in fashion design beyond its role as a tool. By investigating the ontological dynamics of digitally constituted bodies and textiles through the lens of interaction, using agency realism as its underlying theory. Following Karen Barrett's definition of agency realism, we shifted our focus from the things and objects of design toward how they relate to and engage with each other. Movement as the connecting phenomenon between the body and textiles was chosen as the basic ontological unit to explore them in their entangled becomings that were made visible with the utilization of digital technology. Following this conceptual approach was intended to point out the mediating and constituting agency digital technology can hold for designing and experiencing the body and textiles, and to suggest the potential use of digital technology in fashion beyond its utilization as a tool. A textile robot installation was developed for exploring alternative ontological and hierarchical relations between the body and textiles through digital movement translation in real time. The installation had physical and digital aspects. For the physical setup, 3 robotic arms produced by KUKA were used within a confined space. Within this space, they were positioned in close proximity to each other while leaving enough space in between for various movement expressions among robotic arms, textiles, and the human performer to emerge. Furthermore, the movement radius for each robotic arm was adjusted so as to avoid collisions with other solid objects or bodies. In addition to the robotic arms, textiles were used that were attached to the robotic arms with respect to various exploration setups. The digital setup consisted of a desktop computer, the Visual Live Programming Environment V4, a KUKA robot controller for each robotic arm, the Robotic Real-Time Interface RSI, and the Perception Neuron Pro motion capture system. The motion capture system consisted of 17 wireless motion capture sensors that transmitted rotation-based movement data to the connected software Axis Neuron Studio. Here, the movement data was streamed to V4, where the data was mapped and translated into commands for the robotic arms in real time. Connecting the physical and digital aspects of the installation involved understanding how and to what extent the movement and translation process was determined by the affordances of the employed movement sensing and movement enacting technologies. For this purpose, the kinesthetic robotic arm system was explored in terms of how the robotic arms moved in comparison to human armature. While each robotic arm consisted of 6 moving parts, the human armature for motion capturing consisted of 17 moving parts in comparison. Consequently, 3 robotic arms were used to increase the number of moving parts for the movement execution from 6 to 18 in relation to the 17 sensors for motion capturing. This allowed for a more faithful translation from movement sensing to movement enacting. In the second step, translation patterns from the humanoid armature to that of the installation were developed. As can be seen here, the armatures of the 3 robotic arms were seen as one that would later interact with the textiles in between them. The sensors of the humanoid armature were assigned numbers to later determine which part of the robotic armature they would be connected with. The example shows that lines between sensors were sketched in the humanoid armature to create relations between them that determined what parts of the robotic armature would be connected in relation to others. 15 motion capturing sensor configurations were developed to explore the influence of armature configurations on movement translation on the emerging relational body-textile expressions. For this purpose, the installation was run with each sensor configuration in real time for 60 seconds respectively, with a fluent transitioning between them. Once the setup was completed, we used the installation within 3 main explorations. Exploration 1 used 1 triangular-shaped textile, while Exploration 2 used 6 triangular-shaped textiles, and Exploration 3 used a textile structure consisting of elongated diamond-shaped textiles that were stitched together. For all explorations, the textiles were attached at various points of the robotic arms. Additionally, 2 sub-explorations were conducted for Explorations 1 and 2, and 3 sub-explorations were conducted for Exploration 3. For sub-exploration 1, the sensors were attached to the textile, which allowed it to act as the movement sensing and movement initiating agent. For sub-exploration 2, movement sensing and movement initiating agency was given to the robotic arms by placing them across the 6 axes among the 3 robotic arms. For sub-exploration 3, the sensors were placed on the performer's body to translate his body movement for animating the robotic arms. Our analysis and comparison of the video recordings of the explorations and sub-explorations led to 4 key observations concerning alternative ontological and hierarchical readings of body textile expressions made visible with the utilization of digital technology. Observation 1. Explorations that had the motion capture sensors attached to the textile suggested alternative hierarchies in what we perceived as movement initiating and movement responding bodies among textiles, robotic arms, and the human performer. Placing the sensors on the textile changed its role from responding to movements enacted upon it by other bodies to a sensing body that enacted movement on other bodies it was connected to. To enact movement, the robotic arms became reactive actuators of the textile that initiate movement based on the textile's commands. The textiles and robotic arms together turned into a hybrid body system for which the various involved physical parts were connected with each other based on the movement data translation, regardless of their spatial distance. Observation 2. Transforming textiles into movement sensing agents by attaching motion capture sensors to their surfaces meant that the movement expressions of the robotic arms were less clearly initiated by them. At various moments, the movement of the robotic arms seemed to relate more closely to textile movement in terms of acceleration, range, and patterns of movement. By gently swinging back and forth, repeating movement patterns with unexpected deviations, and becoming increasingly fluid, continuous, and organic, the movement expressions of the robotic arms seemed to be more associated with the textiles than robotics. Attaching the sensors to the robotic arms in comparison led to movement expressions of the robotic arms that were visually more disconnected from the textile movement. Observation 3. Observing the interactions between the human performer and the textile robot installation in Exploration 3.1 suggested a mutual dialogue between all involved agents, with each equally active and reactive to one another. The human performer responded to the movement sensing textiles, which were attached to the movement enacting robotic arms. The contractions and expansions of parts of the textile structure continuously changed the space in which the performer moved. As such, the performer changed position and posture in response to the textile moving closer and intersecting with parts of itself. Consequently, the performer moved not only his body, but also the sensing textile by rotating it around himself, lifting it over his head, and moving underneath it. The textile responded to this by moving with the help of the robotic arms in different positions and configurations, which in turn led to reactions by the performer. Observation 4. The unpredictable translation of movement expressions by the textile robot installation suggested that movement data can function as an entangled design material. Setting up 15 sensor configurations, as previously mentioned, did not result in any changes in the expressions of the movements of the robotic arms that could be clearly traced back to the sensor configuration that was active at any given time. Yet the abstraction of movement input that was performed by the textile robot installation and how this enacted physical movement expressions through textile and robotic arms created the impression of a more autonomously acting hybrid body system due to the added degree of unpredictability. In summary, rather than taking how the body and textiles act and react, as well as function in digital environments to be given and predefined, could guide designers in fashion to question and interact with data as a material for design. As such, we believe that the presented research can contribute to an increasingly becoming digital design discipline by suggesting conceptual openness toward relational affordances and meanings of the body and textiles when experienced and engaged with through digital technology. Thank you for your time.